Welcome to the first lesson of the course Modern C++. Assume that you have the basics of the language. So I assume you know pretty much everything about C++ 98 or C++ 2003. This course is meant to learn the new features of the language. Move semantics, smart pointers, all these goodies that are now in the language. Let's talk about move semantics. So let's take a variable x equals to 1. Now we want to take a reference to it, so we can make something like this. This is just a reference to x, and if we modify I, then x will be modified as well. Then we can take a const reference to it. It's the same thing, but we can now not modify I now. Let's try to take a reference to a temporary object. This is not possible in C++. You cannot take a reference to a temporary object. Now, let's talk why we can't make this. There are two kinds of values. L values. L value is any variable that has a name, an address, and we can take its address. So x, in our case, we can take the address of x and it has a name. So x is an L value. 1 doesn't have an address. We cannot take the address of 1. And it doesn't have a name. So 1 is not an L value. The values that are not L values are called R values. As you can see, L comes from left and R comes from right. Now here we try to take an L value reference to an R value, and that's not possible. But since C++ 11 we can make something like this. In C++ 11 was introduced R value reference, and now using this new feature of the language we can take references to temporary objects using R value references. Now let's say we have a temporary object and we want to make a copy of it. So we can make something like this, and f returns a temporary object and will be copied into A. Then maybe the copy can be expensive, so we don't want a copy sometimes. Sometimes we have no choice, so we need to make a copy. But if our object is temporary, we can steal its values, its members, we can steal its memory, because we don't care about the state of the object after this operation. So if our object is temporary, maybe we can do something more clever in order to achieve higher performance. Let's take an example. We have a class A. We have a pointer. Let's make the constructor of this class. Let's say in the constructor we want to allocate this pointer on the heap and make it point to an array of 100 integers. Let's make the copy constructor. Now we need also to allocate memory on the heap and then to copy all the elements from A into our array. So again, we allocate memory on the heap and we make copies of each element from the array. Let's also make the destructor of this class. Okay, now let's say that we make something like this. we default initialize A. So now we have an A default initialized. Now, if we make something like this, then the copy constructor will be called. So we will make a copy of A. The pointer will be the pointer will be allocated on the heap, and then we will make a copy for each element of the array. But that's not optimal when A is just a temporary object. In this case, it is not. But let's go to move constructor. Move constructor, as you can see, accepts an R value reference. So a reference to a temporary object. Now, because we know that A will be no longer needed, we can take the pointer from A and put it into our class, and that's basically it, and then make A point to null pointer. So let's see how we do this. As you can see, we transferred the ownership. Now our class, our object, is the owner of the data where the pointer points. And there's no allocation on the heap, there's no copies. This is perfect. Now let's look at std_move. std_move is basically just a static cast to a R value reference. So we can make move of A. Move of A does nothing to A, but it casts it to an R value reference. So now we can make something like this. Now A is casted to R value reference, and it will be moved into C. There will be no allocation on the heap and no copies. So this operation will be very cheap. In general, move operations are extremely cheap. That's why they are able to make our code much more efficient. That's basically it. One more remark. After we move from A, we cannot use A anymore, because it can be undefined behavior what will happen in the future. Thanks for watching. Hope you enjoyed.